So first up for the lightning talks, and I'll go stick my head out in the hallway and ask people to come back in, or maybe April can do that since you're right there near the hallway. Okay, first up we have Diamanti. Who is our speaker from Diamanti? Did you put slides here? Are you bad boy? Spanking Sean. I'm just saying. Oh, that's okay. That's improvement from one of our other speakers. Okay, you're gonna have a big old clock staring right at you that counts down from 5 minutes. I didn't bring the squeaker. I've done this in so many meetups and it's super fun. I've got this little kid's toy and it's really loud and I squeak it and everyone in the room like jumps out of their skin. Oh, did you put the, there you go. But I forgot to bring that to Seattle. I didn't have time to go. I know, I thought about doing that too, but I think that we're going to be kind of on the honor system here, and we trust Sean. We trust him. So take it away. First of all, round of applause for all of our sponsors, the 8 people that put this together. Yay. And now you get to hear from them if you haven't heard from them yet. Whenever you're ready.
I'm ready. Hey everyone, I'm Sean Roth. I'm Director of Product Marketing at Diamanti. Shout out to the team back there. Essentially what we are is a bare metal container platform. So we give you an entire Kubernetes stack. It's a turnkey solution which currently deploys as a 1U appliance. Just by show of hands, has anybody actually tried to roll their own infrastructure for deploying Kubernetes on-prem? Okay, fair amount of folks. Obviously not an easy project to wrap your hands around, but just shout out how long it may have taken you from top to bottom. Months? 6 to 9 months, anyone?
It just depends. If you do like, if you complete the whole process once, right, and it's automated, it just takes a couple of like minutes, whatever. But the initial process will take like longer, depending on what kind of you have.
So your mileage may vary. Essentially, you know, we saw this as a huge challenge. Actually, there are 3 challenges that that we solve with Diamanti. The first, obviously, is building the container stack from the ground up. So we offer a hyper-converged appliance with compute, network, and storage. We ship with unmodified versions of Docker and Kubernetes. Essentially, you rack this in your data center, connect it to your layer 2 switch, and you can deploy your containers in 15 minutes. It is literally that simple. We give you all the management capabilities to deploy your pods. You can set QoS per container. And that's part of the innovation that we've developed, is taking the network and the storage requirements for containers and then solving those 2 problems, not separately, but together. And so our IP is really a combination of virtualization for networking functions, so every container gets its own IP address, and then offering persistent storage, which is tunable, as I mentioned. So inside the box, we feature fast NVMe flash storage. As I mentioned, all you have to do is connect our appliance to your layer 2 switch, and you have a whole management console at your fingertips. So this is highly scalable. For those of you that are looking to deploy and manage your containers on premise, this is an ideal solution, which you can basically have this up and running in minutes versus several months. So several of our customers are in the financial services space. Others are in digital media and energy. We're based in San Jose, California. And if you'd like more of an in-depth demo, I'd be happy to take you through it. Come visit us at our booth. And 2 minutes left. Thank you very much.
Oh, really? Oh, wow, okay.
That was all right.
I didn't even have time to get that tweet out. Okay, so thank you, Sean. Thank you, and thank you so much for all you did in the last 13 weeks, and everybody. But I'm going to thank you all individually, because these have been my brothers for 13 weeks. We've been doing a hard time together. Okay, do you not have slides? You just have a notebook? Oh, okay. I was like, He's going to read us some poetry. I was getting excited. Yes. Lightning Talks and Poetry Slam. Container storage style. By the way, you can take the whole 5 minutes. You don't have to have the setup time and be part of your 5 minutes. We're still in Sean's. We still have a minute of Sean's talk. Okay. Clicker. What do you think this is? Is there a clicker? Clicker? No. Who needs a clicker? Wait, hang on. Hang on. Gotta reset this. Gotta keep you honest.
It looks a little different than full screen, but
Is it not working if you forward it yourself?
whatever. We'll go with it. Hello, everyone. I'm Georgi Matef. I lead product at Kasten. I have the pleasure of being the second out of 8 speakers between you and drinks. So I'm going to try and keep it short and sweet. So we heard a lot today about persistence and storage options for Kubernetes. We also heard a little bit from Vlad and Mike earlier about what it takes to get some of these building blocks and actually deploy stateful applications that use them and maintain them in production. So I want to double down on this and talk to you about data management from an application point of view, which is a topic that's near and dear to us at Kasten. So we as a company are focused on some initial use cases within data management, specifically data protection, where we cover backup and recovery as well as disaster recovery for your production stateful applications. Also, application migration, where we allow you to move complete application stacks, including the underlying data between clusters. Oftentimes, these clusters might be running on different infrastructure, so that's something that a lot of people find useful. So before we cover kind of the specifics of our approach, I quickly want to walk you through what we consider sort of a prototypical stateful application. So we have a kind of stateless front-end service, which is backed by a number of microservices. We'll focus on 2 stateful ones in this case. One is storing unstructured data on a PVC that's backed by a volume from a storage provider. And the other one is capturing structured data, in this case, in the managed service from a cloud provider. But this really could be a database running in the context of the application. It could be running somewhere else on your Kubernetes cluster. It could be running somewhere else in your environment. So how do you deal with data management in this context? And not just this application, but if you were to have to do this for a very large number of applications. And the way to do that is really to treat the application as the operational unit, right? So traditionally, a lot of these tasks have been approached from the infrastructure level, and we've decided to turn this on its head a little bit, where we allow people to capture their entire application stack. So all the Kubernetes resources, all of the underlying data persistence, regardless of how that might be expressed. And we take care of kind of abstracting all of that away, so you don't have to worry about the underlying infrastructure, which is pretty nice. And last but not least, we help you kind of orchestrate the process of doing all of this so that you can have the right level of consistency that you desire. And we've expressed this philosophy in the Kasten platform, which is our enterprise offering. This targets really cluster operators who are looking at operating infrastructure for the entire organization, multiple teams sharing these clusters, oftentimes multiple BUs. And for these folks, it's important that they're able to do all of this across a very large number of applications, like hundreds, if not thousands of applications. Oftentimes, they don't even know what these applications are ahead of time. So for them, we offer several things. So one is being able to discover the applications running on these clusters automatically. So we'll discover all of the application resources and all of the persistence associated with the applications. Then we give you the ability to express through policy, what are your business objectives around backup and recovery and migration. We also take care of scheduling and executing of these robust workflows. And last but not least, we help you monitor all of these operations so that if there are problems, you can kind of quickly take corrective action. Why this is great, we oftentimes realize that for some of these applications, you need to be able to extend the logic around these data management operations. So for that, we have a framework called Canister, which is an open source framework that allows you to basically create recipes for applications that need custom handling. And you can drive these then through K10, or you can integrate them in your own scripting as needed. You can find a lot more about this at GitHub. And all right, come see us at the show floor. We have 2 talks, a lot more about these topics. One is on data protection. The other one is on CI/CD and data. And come talk to us at the back.
All right, give him a hand. You weren't going to tell me that my computer reset and the screen went black, were you? He was like, I didn't see the timer. We got to have rules here, people. I realize that there's just now 6 more talks between you and beverages. Oh, and incidentally, when you go pick up your shirt, pick up your drink tickets. That is how it's going to work, apparently. I was just told to pass that along. So I think we're handing out 2 drink tickets or something like that. If you don't want your drink tickets, you can donate them to someone else. Is it what? If you plug this in, this will show there. Either one. Whatever one is on.
Hello? Yes.
All right.
It's been a long day. Thanks for staying up, staying awake. I've been exhausted and excited at the same time, so I cannot show my emotions really. Then I'm gonna use some help from my emoji. So at MayaData, our mission is to deliver data agility. Our software and solutions cannot be really neatly slotted into legacy IT categories. We don't just connect to storage, we refactored storage. And we use today's technologies to deliver storage for today's cloud-native application, today's workloads. And to be able to do that, we focus on a few points. One is DevOps autonomy. Teams fully retain autonomy and control of their workloads as well as their storage system. And we remove bottlenecks so that engineering teams and developers continue to innovate faster in an agile way. So we design a storage system that is completely cloud native itself, and granular workloads and level of control of anything storage related to you can think of. And amazing, never seen in storage like simplicity. So in seconds, you have seen a demo, you can get a complete storage system up and running with your application. And at last, freedom from cloud locking. One of the presentations, you also showed that most of you are in hybrid cloud. You need abstraction in control plane. That is a huge benefit. So we have seen this before many times, of course, before cloud and DevOps and applications were tightly coupled. And we were dealing with synchronized releases that happens maybe a month, or we were dealing with ISOs that is released 3 months, and slow cycle times. At the same time, storage was fragile. So that's why we moved into DevOps agility. So now applications are loosely coupled, yes, and small teams that are delivering more frequently, more agile, and fast release cycles. Everything is built to fail, but that works for stateful only. Stateless only. So DevOps was blocked by stateful. Agility of DevOps was blocked by stateful. All stateful workloads tied together via storage. Lack of team control over storage. You have to ask your storage admin to deliver, and pipelines were blocked, not agile, and cycle time slower. System behavior difficult to predict. At the same time, each cloud and SAN behaves differently on every cloud. So with MayaData, we put teams and developers back in control. Workloads are kept safe. Running storage itself in a Kubernetes way, cloud native way inside your cluster. No additional single point of failure introduced from storage black box. Lock-ins, cloud lock-ins, all the infrastructure lock-ins eliminated. And you start to see common behavior from different cloud vendors or storage systems. So to be able to do that, in our commercial solution, MDAP, which stands for MayaData Agility Platform, we stand on a few components. Obviously, Kubernetes is the orchestration platform for container itself, but OpenEBS and our components live inside that ecosystem. OpenEBS now today has over 370 contributors, close to 2 million Docker pools and many GitHub likes, one of the most popular open source containerized storage system. So we provision storage using OpenEBS. And then to be able to build trust, we have another open source solution called Litmus. It is a chaos engineering tool and at the same time end-to-end application and storage testing tool. By adding Litmus into the picture, we are also trying to build trust that more developers can build their stateful applications. And on top of that, Maya Online, it's a SaaS dashboard, adds control and visibility to your environment. So we have, so you can get services like data migration.
And that's 5 minutes.
And that's it.
Well done. Well timed. Well timed. Oh, I have another laptop for sale if anyone wants one. Oh, is that yours? No, it's somebody who loves VMware. I'm guessing it's Steven's. Okay. I mean, not that we don't all love VMware. What was that comment earlier about containers? Kubernetes is the next VMware. I don't know where someone made that comment in, maybe it was the security panel. I was like, what did they just say? All righty. Mr. Rao, let me reset. But it's not showing anything. Do you need the white one? Hang on. We're not taking this out of his 5 minutes yet, but we're charging him $20 for every minute. And that's going to go to our drink fund. Mine personally. That was working for me earlier. Middle one, I think. Maybe it's your laptop. Is there like one of these situations that we need to push? What happens if you push like those things?
Why don't we go with somebody else, and then I'll go test this and come back.
Just put it on the Google Drive. That was. Okay, so next in line is going to be Steve. No, other Steve. Thank you. You're Steven.
I loaded it on the share.
See, somebody followed instructions.
I'm a fast talker, so I'm going to use my 5 minutes.
Gold stars for everybody that actually followed instructions. You loaded it here? Is that you?
Yeah, the red
Look
one.
at you. Yeah. Makes it
Should I
easier.
use this one? Yeah, that's on.
All right, hang on.
All right,
Wait.
can I start?
You trying to buy an extra
I can
30
talk,
seconds?
yeah.
Oh my gosh. Wait. Okay, maybe the problem is, Nathan? It's possible that it's not us. Did someone trip over the projector cord? All right. Apologies to Mr. Rao. It's possible that it wasn't a user error. Ha ha ha. You did say that before, but how did it get switched? Okay. Sorry. Hang on. And now what? Do you need to what?
How do I advance?
Yeah, try the download network. What about the? Oh, I can't do this from here. How did you guys advance those a second ago? Was it the space bar? Aha.
Can I go back?
Of course you can. Maybe. I don't know.
Yeah, there we go. Okay.
Oh my gosh. Okay, ready?
Oh, nice. All right.
And go.
I'm Steve Bohek, work for Red Hat. I work on the Openshift storage marketing team. Actually, I run Openshift storage marketing. But I'll do a quick flyby. But before I do that, a quick survey. I think we did some of these surveys already, but let's just reset. Who's running Kubernetes? I know it's a dumb question. I'm going to ask it anyway. Keep your hands up, please, because I want to. Of you guys running, who's running bare metal? Okay. Who's running in VMs? Okay. Different survey. Who's familiar with Red Hat Openshift? Okay. Yeah, keep your hands up, please. Of you guys, do you know that we have storage products from Red Hat? Okay. That's what I'm about to expect. All right. One of them is Openshift Container Storage. So Openshift Container Storage is actually based on Gluster. I'm assuming you guys are probably somewhat familiar with Gluster, one of our other storage products. It is, we kind of say it's the de facto storage for OpenShift, not surprisingly since it's called OpenShift Container Storage. It has two, without getting too deep into the weeds, it's got basically two basic deployment models. One is the traditional kind of hyperconverged, which I think we've talked about several times today, that actually runs on the same infrastructure that you run on OpenShift, whatever that is and wherever that is. And then the other one is actually kind of more of like a go-between if customers want to use their existing traditional storage with their OpenShift deployment. This can actually be run between the two to help establish some of that dynamic provisioning we've been talking about throughout the day. So those are the kind of two basic ways to use OpenShift Container Storage. The lion's share of people tend to do the first one, which is hyperconverged. Because one of the things that happens as our guys are out talking to customers around OpenShift in general, you know, that tends to be new deployments where they're starting fresh, and in those situations, it's best probably to think about storage in the beginning and probably just use that hyperconversion, just deploy a new storage model with that OpenShift deployment when it's launched. So that's like the lion's share, I would say, of the time of what we see. But like I said, it's built on Gluster. Scales into petabytes. It is actually developed, optimized, or developed and maintained in sync with the OpenShift versions itself. And what I mean by that is, you know, the latest version is OpenShift 3.11, right? The latest version of container storage is 3.11. So they're announced and kind of developed in sync with each other. The only other quick caveat I'll say is that I mentioned it's based on Gluster. That doesn't necessarily mean OpenShift Container Storage does not equal Gluster. In other words, there are differences between the two products, but its foundations are Gluster. And then the last thing, of course, and this is a lot of customers like it. It is, you know, one vendor to call for your entire container deployment on OpenShift, whether it's the storage part underneath or the actual, of course, container orchestration environment. And then the last thing I'll say before I go to my next slide is that don't think of this as necessarily just the application data I'm talking about. There's also storage that OpenShift itself needs and uses as part of the infrastructure, right? Metrics, logging, and the registry for where the images are. All that can run on OpenShift Container Storage and does in a lot of our customer installations. This is a kind of a quick flyby slide, but we've talked about this. I think throughout the day, like I said, anywhere OpenShift runs and is deployed, OpenShift Container Storage can run and be deployed in that same place. And these are some of the options. many customers, I think, as we've heard and seen today, are kind of running both of them for various reasons, or a combination thereof, as I think Aaron mentioned earlier. It's the hybrid approach. All right, in the interest of time, just real quick, in terms of where can I try it out or play with it, we actually have an Openshift test drive, and that's what this is talking about, and then Openshift Container Storage is like the foundational element of it, so you're kind of playing around with both of them as you do test drive. I can't remember what, I think, yeah, it's 8 hours complimentary on us to try it out. So it's linked in the slides. You can go there and check it out. And then lastly, all the different places you can kind of hear and see what we're talking about. I think I put my Twitter handle on the first slide. I've been tweeting throughout the day, and I tweet a lot about what we've got going on. But feel free to connect with me afterwards, and thanks for your time. Appreciate it. Nice to meet you.
Thank you. And thank you for your honesty. I know you saw what happened there. Thank you. That was partially on the honor system here. Appreciate it. All right, Gu, I think the problem was that got pushed, and it needs to be on number 3.
I'm going to be very far away from that.
I don't think he pushed it. We're not naming names. Just saying. It's possible.
All right, there you go. Second time's the charm. All right, I'm going to try and make up for the lost time here, but
Hang on. Oh my gosh. Okay.
all right, okay.
Go.
My name is Gu Rao. I'm with Portworx. What is Portworx? Portworx is a software-defined storage overlay. So I'm going to kind of describe that with this slide. When you install Portworx in a Kubernetes environment, there's a Portworx agent that runs on every node. Its job is to virtualize the physical storage resources that are available to it. So I'm going to talk about why you're doing this, but essentially what it does is once you have Portworx installed in your Kubernetes cluster, whenever you deploy a stateful application, you have a persistent volume claim. If it's coming from Portworx, these virtual volumes are bound to a particular container, and they're available anywhere in the cluster. So why do you run a storage overlay? So like StorageOS or Portworx or Roth. The reason you're virtualizing the storage infrastructure is because first of all, you don't want to have a direct one-to-one relationship between the hardware asset, the physical storage that you have, and the containers that are consuming them. Some good points are made in the security panel as well, why you wouldn't want to do this. Essentially, the benefits that you get from having a storage virtualization layer is you get to, you have a difference between the number of applications you're running and the actual physical resources that you have available to it. A very specific example is if you're running in Amazon and you have EBS, you're using EBS volumes, you may be running thousands of containers, and the last thing you want to do is allocate thousands of EBS volumes that way. So the density is a lot higher. You're running a lot more applications. The other really, the immediate problem that you're going to run into, and I think we've been talking about this throughout the day, is the availability. So you want these volumes to be available on any node in your cluster, whether you're running in the cloud or on-prem. You have probably different data centers. So you want these volumes to be available anywhere the container runs. In other words, you don't want to pin a container to a certain node. The other thing is that your applications are not just one container, right? So and typically an application, especially a cloud-native application, like in this example, I'm talking about Cassandra. It's at minimum you'll have 3 containers. So when you provision storage to your application, you're not provisioning storage to one container. You're provisioning storage to 3 different containers. So any kind of volume lifecycle management that you want to do for your application needs to take into consideration the overall application scope. Go past this. We talked a lot about CSI. Portworx leverages CSI to deliver all of the value that we're talking about. I'd like you to, if you can, please go to our doc site, docs.portworx.com. If you go, there's a link there to a number of different Catacoded tutorials. We've spent a lot of time trying to create elaborate Catacoded tutorials, so please try it out. It's a live environment. If you haven't used Catacoded before, it actually, you don't have to stay with the script. You can break out of the script and try your own experiments. You can see how you can run complex applications. Good example, my favorite is the Postgres example, where we actually induced day 2 failures. I think there were some talks earlier today that talked about day 2 operations. I have another minute and a half, so I want to actually talk about a multi-cloud workflows here. So again, go to the Catacoded site to try out all those examples, but today's theme, and I think in this KubeCon in general, you'll see a lot of discussions around hybrid cloud and multi-cloud workflows. I know Bassam and Aaron talked about a lot about multi and hybrid cloud. So I want to do a quick demo. So in this case, what I have is on the right-hand side, I'm running a Kubernetes cluster on-prem, and it's running in a virtualized environment. So just basically single master, 3 nodes. So let me expand this. In this example, I have a Postgres PVC bound to a single Postgres deployment, just execute into the Postgres application over here, and I have about 5 million records. So when you install Portworx, another thing gets deployed, which is called Stork, which is a storage orchestrator for Kubernetes. What I can do is basically get my cluster pair, and I will cut over to my GKE cluster and pair my GKE cluster with my on-prem cluster. And now what this lets me do is I can now use Stork to start a migration of my Postgres database. It will take a snapshot of Postgres. And if I go over to my GKE cluster, I can see that Postgres has been migrated. I'll basically execute into the Postgres database. Not only do I have the data, I also have the PVC. And my entire database is intact, and that's it.
Wow.
So, yeah, please come and visit us at the booth.
I did not think he was going to get through that. That was courageous. A demo in your lightning talk and slides. That was, I can't believe you actually got that in the time. Okay. Thought I was going to have to kick my own CTO off the stage. That was going to be awkward. Okay. You're doing your own. Okay. Let me take this back. See how they just leave these things. Wait for it. Wait for it. Nice. Result. Go, Alex. Boom.
So, I was thinking 5 minutes is too short for a product pitch. And a product pitch at this time of the evening is boring. So, I was going to put together a summary of everything we heard this morning. And then I thought, yeah, my head of marketing is probably going to kick my ass if I don't say something about the product. So, this is it. StorageOS is a software-defined system. We're deployed in a container. We virtualize all your underlying disks, whether it's physical, bare metal, or cloud volumes. And we allow you to run your production clusters, your enterprise class systems in stateful workloads on Kubernetes. We're software-defined. We're a cloud-based system, no dependencies whatsoever. So we're platform agnostic. That's one of the principles we discussed this morning. We scale horizontally, and we provide all the replication and inline compression and encryption that you expect from data services in a storage platform. We integrate with Kubernetes, Openshift, Docker, and all the other orchestrators, and allow you to move your stateful workloads, primary data, what we call primary data, so things like databases, message buses, that sort of thing. And you can continue to have your high availability in your applications because your storage is now highly available too. And I'll put up this to say that's my email address, and you can connect to us on Slack, and you can give us a tweet. And Jared commented earlier when he looked at my Outlook that I had 10,000 unread emails. That's probably why, but I promise I'll read your emails if you send them through. So, the more exciting bit, and this is full of exclamation marks, and it's meant to be a little bit funny, but it's kind of cool because there were some really interesting themes today. So, finally we said, there is no such thing as an application that doesn't have states. Quinton started by saying that stateless apps are a widely misunderstood myth. I then came on and said, well, all architectures need to store state somewhere. And then Vlad and Mike came on and said, no, really, there really are no stateless applications. So I went, awesome. Because we can now finally say this, and I took the picture that Quinton used in his presentation, because that was cool. Because StorageMan tells us that there are lots of storage options. We have lots of storage systems with lots of different storage attributes, and covering things like availability, performance, consistency, and all of those things. And what's really important is to choose your storage based on your application requirements. And to do that, you really do need to understand a little bit the different types of storage topologies, the different types of data access interfaces, and how you orchestrate and manage them. So the data access interfaces and those orchestration management interfaces that we talked quite a bit about, whether it's with CSI or file, block, object, etc., are really, really important. But you need to remember that you also need to figure out the topologies, because so many of these things are layered. Now, in order to try and make this a little bit clearer, we put together, together with the CNCF and a couple of guys in this room, we put together a storage white paper to cover the different aspects of this in the landscape. And I'm going to be giving a talk with Quinton on Wednesday, so go for our deep dive session there. The important thing is you no longer have to let storage shape the way you deploy your applications. You can now choose different storage systems or different storage parameters for your applications. We also learned orchestrating statefulness is hard, and customers just want to run their applications and have their storage requirements abstracted. So this kind of takes us to the composability and the declarativeness that we want from our systems. And we also heard from the day two presentation that users will surprise you, and they will try and do things that you haven't thought of. So you do need to test and evaluate your storage. There's people often come to me and say, how many IOPS do you do, and how much throughput do you do, or what's your replication like? And you kind of have to say, those are how long is a piece of string sort of questions. You kind of need to test it in your environment. Different cloud environments have different characteristics, different on-prem systems have different characteristics, and if you're really going to figure those things out, you need to try them out. We had Steve Watt come on and talk about all the evolution from different storage systems, from single service to scale out, and now clusters with multiple properties. And we also heard about some of the exciting stuff coming up in the future. We also had the CSI session, which was really, really popular. And CSI is cool because it allows orchestrators to talk to lots of different vendors. And now you can choose your different storage systems accordingly, because declarative storage is cool. And finally, we ended off today talking about cloud and multi-cloud. And we heard the different cloud panels saying that the cloud providers are looking to standardize the storage. We heard the multi-cloud panel say that data is sacred. And we are also now looking to the future, where we have multi-cloud and hybrid clouds saying that portability is really important. Volumes need to be everywhere. But we also need to create abstractions for things other than volumes. So you remember early on in the day, we said there are volumes and there's API access. Volumes are well mature. API orchestration, less so. So tomorrow, maybe multi-tenancy and federation. And with that, I'll end.
Wow, also right on time. You guys are paying attention. Thank you for that recap. And thank you again for all you did. Alex was a huge, huge part of getting this day rolling and putting it together with us. Thank you so much. So is your stuff here?
Yeah, it's on the shared laptop there. Should be in the Lightning Talks folder.
That's the Lightning Talks folder.
Oh, sweet.
Oh, sweet.
Full screen it and make it big.
Let's do that, because otherwise your slide notes and things like that are being shown. And then some other people's and James. I think these are better now. Okay. Jared. Oh, wait, hang on. My laptop is almost dead here. Which is why it keeps going to sleep on you guys. Are you ready?
Oh, you got a timer right
Deep
now.
breath. Of course I do.
I've got my own independent timer here.
Oh,
for
did you?
Verification.
You might have been the most organized of all of
But
my
I really do trust you,
cohorts.
Lisa. It's been a good 13 weeks working together, I promise. All right, shall we?
Go.
All right. So I'm going to talk about the Crossplane project. My name is Jared Watts. I'm a senior maintainer on this project, and I'm also one of the founding engineers at Upbound. So let's get into it. So Crossplane is a brand new open source project. Literally on Tuesday of this week, we just made it public and just open sourced it. So it hasn't even been on GitHub for a week yet. But what it is it's an open source multi-cloud control plane. So that means it spans across different cloud providers, different regions. even on premises, and it's based on Kubernetes, so it uses the same declarative management style API that you're used to with Kubernetes already. So you can tell it, declare what you want it to do, not how to do it, and it takes care of it for you with smart controllers that can model and manage resources and infrastructure and cloud providers and on premises as well. And what this does is this enables workload portability and reusability across all environments. We're going to get into that more in a bit here. And it's also got a really smart scheduler to dynamically choose the best fit for where your workload should go. You're dealing with all these different clouds. Where should the workload go? The scheduler can figure that out for you. It also has a separation of concerns between developers and administrators to kind of get you to focus on just your application, or not worry about the specific details in your environment if you're a developer. And it's, I mentioned it's open source, it's community driven, it's extensible, so we're going to start growing this community on this project. So first of all, why multi-cloud? We talked about this a little bit, and for me, it comes down to the power of choice. For your application, you want to be able to choose the best place for it to run every single time. There's a bunch of different parameters you might want to choose on, cost, functionality, compliance, all sorts of things, but multi-cloud's good because you get to choose the right place for your workloads to run. Talking about the declarative API, we believe in its a convergence on the Kubernetes API. So what that allows us to do is native integration with kube control, as well as other tools and libraries and user interfaces out there that manage interact or interface with the Kubernetes API. There's a super rich ecosystem and community out there that's been growing around Kubernetes. This KubeCon, I think, has 10,000 people or so. So this community is getting huge, and Kubernetes is really showing itself as a powerhouse of container orchestrators. There's a lot of lessons we think that were learned from container orchestration that we can start applying to multi-cloud workloads and resources as well. So when we talk about resource management, so Crossplane has a set of custom resources, and what those do, they model different cloud provider resources as well as some of their infrastructure as well. So for instance, in Amazon RDS database, there's a custom resource that models that for you. There's also custom controllers that run, say you create an instance of that RDS database with kube control. That custom controller will pick that up and use the Amazon API to make that RDS database come up for you on demand. And the good thing about this is it's not just run once and and the controllers stop at the initial deployment. It's active reconciliation. So as things go wrong, or health monitoring, or day 2 operation stuff, these controllers and these operators will do that over time for you actively. So here's a little picture of what it looks like. So basically, the middle is a very important part, that it's, all the Kubernetes API machinery is there. We got the scheduler in the top right. We have our resource controllers and some third-party resource controllers as well that all build on that Kubernetes API machinery. And since it's using the Kubernetes API, that allows us to use kube control, other libraries, UI, and such on the left side to interface with it. And then on the right side, we have all the different cloud providers, Amazon, Azure, Google Cloud, and some third-party independent cloud offerings as well that these controllers manage for you. So this is a really good part here is this allows portability. So these, instead of just modeling specific cloud provider resources, there's also these abstractions on top of that. We talked about this earlier in one of the other talks, but things like databases and buckets and clusters, Kubernetes did a great job at abstracting a volume for you, but let's take that further. Let's model other things so that your workload that uses things that aren't just volumes can start being just as portable as pods and volumes are. And so we want you to be able to write once your application and its resources, and then be able to run that anywhere. Any cloud, on premises, doesn't matter. 30 seconds. So separation of concerns allows the developer to just worry about their application and not worry about the details. Let the administrator deal with that. This is similar to storage classes and persistent volume claims for a concept of resource classes and resource claims for all sorts of things, buckets, message queues, databases, everything. And also the scheduler, the purpose of that is to be able to optimize for the right place to run your workload for the right parameters, policies and cost and compliance, availability, features, all that sort of stuff. Scheduler will figure out where it's going to go for you. And there's ways to get involved on GitHub at crossplane.io. And tomorrow, go see this talk. It'll be a live demo of Crossplane running across all the major cloud providers at the same time in Ballroom 6B. Thank you.
Thanks, Jared. And thanks again for all your help over the last 13 weeks. Okay, last, and I know you loaded your stuff because we did it together. Yeah, sure. With your camera?
Yeah.
I'm like, I'm taking everybody's picture. Okay, wait, hang on. Where's the... And you left him up here, right?
It was on a tab, and then it's in the directory.
Do you see which tab is on?
It's
Let's just start it over. And we'll just put it in presentation mode.
okay. Testing. Hi, I'm Steve Wong with VMware.
On. You may
Okay,
begin.
Steve Wong with VMware, software engineer. I've been a contributor to Kubernetes storage since 2015. So I'm going to start this. It's a little weird. I'm not going to go here telling you really about VMware product. One of the things about VMware, I assume everybody in the room knows who VMware is. We really are in a position where we don't have one thing to promote. At this point, we've got Kubernetes, several distributions, and frankly, we can probably support running most of what's on this sponsor list on top of vSphere. If we'd like to see you use our stack to have one throat to choke with both our hypervisor and our software-defined networking, but if you choose to cherry pick individual solutions, we'd be happy to support you. We run in major public clouds as well as on-prem. I borrowed this concept from Chris Meller of the Register, one of my favorite things to read, but he came up with this idea of the storage classification stack, and I think it's important because this is complex, and it builds from the bottom of the physical storage implementation to the interfaces, to things that are essentially software running on top of this. If you're on a public cloud or you're buying appliances, below this line you don't get to choose, but they're still in play and you need to think about them. So it's things about whether the devices are SATA, SAS, NVMe, the interfaces, because these things affect your operation. Even storage ultimately connects on networking unless it's DAS, and they affect what kind of result you get when you deploy Kubernetes in a cloud. So I'm going to go over some considerations when you choose your technology. Number one, do you need cloud nativeness in the sense of portability? I suspect for all of you in this room, if you came here, the answer is yes. But what this means is what you'd like is deploy stateless and stateful applications that can't even tell where they're running and are just going to work regardless. So this really comes down to the three modes in that Meller chart of block, object store, and file. And I would contend that when you're consuming block storage, the kind of things used traditionally by transactional SQL databases, but other apps as well, Kubernetes already provides an abstraction layer, so that's largely going to be portable. You can run another layer on top of that that makes it double portable, but there might be such a thing as too many abstraction layers. So it's almost hard not to get portability these days with CSI and the storage plugins of Kubernetes, assuming you're on Kubernetes. For object store, I think the battle has been won, and I would contend that for object store, the S3 API is a near de facto standard everywhere. It's like every public cloud in the world has elected to provide an S3 compatible API, and vendors who do object stores on-prem are forced by the marketplace to deliver S3 API. Therefore, you shouldn't have unless you're stupid and use some other API to get to your object store, you should be portable. File is the one area that maybe is not so portable. NFS, SMB, Amazon EFS are all standards, but some of these are going to lock you into something. I can't give you a magic solution to that other than evaluate whether you really need to use a file store interface, and if you do, maybe large numbers of those apps are legacy anyway. Often cloud nativeness is also this concept of elastic scalability, that I don't want to go out there day one and be able to 100% predict my needs and not pay as I grow. With public clouds, this should be easy, that what you're buying is scalable. When you're on-prem, you can buy hardware appliances, but they generally scale across a range, and you need to pigeonhole about where you're going to go. They might scale over a range of 1,000 to 1, but they don't go 10 million to 1. With software defined, maybe you can contend that that's easier to put a layer there to allow you that elastic scalability. But what you have to ask when you come up with a solution that purports to be scalable is, look at the technology and ask yourself, will the network bandwidth grow as I grow capacity? Because typically you need that. But there are some technologies that put a head unit on there with a fixed amount of bandwidth from day one, and you throw capacity over it over the course of 2 or 3 years, and network's not growing with it, and you might be in trouble. Likewise, for software defined, they often use CPU utilization, and if you go with something like a hyperconverged, and this can even apply to VMware's own products, you might have a fixed ratio of CPU cores to the amount of storage you can mount there. If you can't predict that over time, and you might get yourself in trouble. So it's just something to consider. Number 3, does your storage also need to support non-containerized workloads? By that I mean, yeah, it's great, greenfield, going into containers, horizontally scalable, it's the new world, it's cloud-native apps, but you might have VMs. Some of these storage solutions were built in a VM era and can easily and obviously support VMs. And my contention is that things like CSI and Kubernetes storage plugins let you simultaneously support both. You have to look at your own workload. If you're 100% container, maybe this doesn't apply to you, but if you've got this legacy mix, maybe even some bare metal mixed in and that isn't even VM, you may want to have one unified storage solution that can simultaneously host up storage for all of this. There's another issue here of, if you have an existing one, sticking with what you know might be lower risk unless the old way just doesn't meet your requirements. Finally, things to ask are, how are day 2 things like capacity expansion and updates handled? I've been to a lot of sessions where they paint this glowing picture of, look how easy it is to deploy this little mini cluster in 5 minutes. And they're not looking at any failure scenarios or faults. And often the day 2 is where you're going to live the rest of your life, not that initial install. You're going to do that once, and then you're going to be faced with what it's like to live like long term. It's like bringing home that puppy where it's great, but you're going to have to pay for vet bills and feeding it over a number of years. Finally, consider network demands. I don't know, am I out of time?
Yes.
Yeah, okay. I'll respect the time.
Thank you so much. Thank you, Stephen, and thank you to everybody